Okay, today's lesson is 8.3 medians and altitudes of triangles. So in this module 8, we've been talking about different segments in triangles. So in 8.1, we had the perpendicular bisectors that meet at a point called the circumcenter. In 8.2, we had the angle bisectors, which meet at a point called the incenter. And today we're going to get another one. So we need to first discuss what a median is. So a segment drawn from the vertex of a triangle to the midpoint of the opposite side is called the median. Okay? Every triangle has three medians. So these are just three examples of three different styles, I guess, or types of triangles. There's a right triangle in the middle. There's one with an obtuse angle on the end, and then the first one has three acute angles. So a median, I'm not going to do this for every one. I'm just going to kind of do it for the first one to show you. So if I used a compass to find the middle of this side right here, I would use a compass to find the middle, and then I would connect the opposite vertex. And that piece right there is the median. The rest of them I'm going to do just real quick, and it's just to show sometimes segments can be inside the triangle, sometimes they can be outside. The medians always have to be inside, but when we do the altitudes later, you're going to see that they can be outside. There's so much vocabulary and geometry. I would hook this median concept to something you know, like maybe the median of the road. If you're driving down a road, where is the median? It's in the middle. Okay, so that's how you can maybe remember this, is that you connect the vertex to the middle of the opposite side, and that segment right there is called the median. So I'm just going to really quickly just go ahead and draw all the medians in here. All right, so it would look something like that. Okay, and same thing for a right triangle. So I'm going to connect this to the middle of the opposite side, this to the middle of the opposite side, and that to the middle of the opposite side. Okay, and then for an obtuse triangle like this, connect this to the opposite side, connect this to the opposite side, and connect this to the opposite side in the middle. So that's just a really quick, rough look at what connecting all the medians looks like. And then you have a point of intersection. So if you connect all the medians, there is a point of concurrency. They all meet at one point, and that point is called the centroid. Okay, so there's a theorem on the centroid, and it says the centroid theorem states that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so there's this 2/3, 1/3 relationship. Let me just focus on one of these. Okay, so I'm gonna focus on like AX here. So I'm gonna kind of blow that up and have A and X, and then you have this point P in the middle, or not in the middle, but it's the centroid. That's the centroid, and that's located right here inside the triangle. Okay. So there's this 2/3, 1/3 relationship. This piece is 2/3 of the total length from A to X, and this part is 1/3. So if you're looking at the triangle and it's asking you to find the short piece, you multiply the whole length by 1/3. If it's asking you to find the longer piece, you multiply the whole length by 2/3. Okay, so we're going to get a little bit of practice with that on the next examples. Okay. So it says use the centroid theorem to find the length. So first of all, it's marked as the centroid. You can see all of these. That's a midpoint because those two pieces are congruent. This is a midpoint because those two pieces are congruent. And it looks really similar to the circumcenter where we did the perpendicular bisectors. But notice there are no perpendicular marks here or there or anywhere. Okay, so they do look really, really similar, except this one will not have any of those perpendicular marks. Okay. So it says find gives you some information here, AF. So the whole thing all the way across to AF, I'm going to mark over here, which is 9. And then I'll switch colors. And it says CE, which is this whole piece, is 7.2. It says find AG and find GF. So let's go ahead and see where AG is. AG would be this piece right there. So we'll go ahead and find that first. So you got to kind of ask yourself, does that look like the longer part or the shorter part of AF? To me, that looks like the longer part. So GF, the next part we're going to find, is the shorter part. So the longer part is 2/3 of the whole distance. So that means that AG equals 2/3 times 9, which is the whole length from A to F. Okay. So you guys, I'm going to show you a couple different ways to do this. You can either do it by hand, which I would maybe not recommend doing just so that we focus on accuracy. You can do it by hand, okay? And this would be 2 this would be 2, let me get a better marker here, 2 times 9 over 3, 9 over 1, like this. And you guys can see that this 9 divided by 3 is 3. So this would be 2 times 3, which is 6. So you can do it by hand that way. I think you guys should practice using calculators. So I'll show you with like the TI 84. With the TI 84, some of you guys have the new operating system, some of you have the older operating system. So there's a couple ways to do this. I'm going to use the fraction key. So if you guys have a calculator with the fraction, go ahead and use it. Type in 2/3 and then times 9, and then your calculator will give you 6. Okay. Or if you don't have a fraction key, you can always do this: 2 parentheses 2 divided by 3. Okay. And then times 9. Or you can do those individually. You can hit 2 divided by 3, enter, and then times 9, enter, and it'll give you 6 also. Okay, so just a couple ways to do it there. So if AG is 2/3 of 9, that means AG equals 6. Okay, so there we go for AG. GF is this other part of it here, so it's the 1/3 part. So AG equals 1/3 of 9. Okay, so another way to say that is 9 divided by 3, or you can use some logic here. If the whole thing is 9 and this piece is 6, that makes AG equal to 3. So any of those ways, you can think about that one. Next one is a decimal, so we definitely are going to want to do it on a calculator. So let's go ahead and do the same thing here. We're going to kind of lay out what we're trying to find. CG, okay, is this piece here. So to me, that looks like the longer of the two. So that means that CG is 2/3 of the entire segment length, which is 7.2. And then that one we're definitely going to want to do on a calculator. So here we go. So we've got 2/3, oops, times 7.2, and that's 4.8. Okay, so again, you can either do the 7.2 minus 4.8 to find the other piece, which is GE here, or I'm just going to do it the same way. GC equals 1/3, since it's the short piece, of 7.2. And so I'm going to grab my calculator again, and this time I'm going to type in 1/3, so 1 divided by 3 times 7.2. And that gives me 2.4. I'm sorry, I labeled this one wrong. That should be GE. Okay, so there's GC. This one should say C. My writing is sloppy there. So GC or CG, either way, doesn't matter, and GE. Okay, so that's basically the gist of those centroid problems. So you're given some information. Part of it is 2/3 of the whole, and part of it is 1/3 of the whole. If it's the medians, and the medians connect the opposite vertex to the midpoint of the opposite side. Okay, this one, it says the diagram shows triangle XYZ, which has side lengths of 8, 12, and 15 inches. The diagram shows the medians, the centroid, and the lengths of some of the subsegments. Apply the centroid theorem to find the other segments. So go ahead and pause the video right now. Try these 3 problems for practice, and then hit play when you're ready to see the answers. All right, so first thing is we need to figure out where LY is, okay? It's right here. So to figure out what LY is, we need to know what a median is. The median connects the midpoint of the opposite side to from the vertex to the midpoint of the opposite side. That's the median. So that means that that point right there is the median, which means that this YL is half of 12. So that would be 6. So this is 6 inches. That one's pretty quick. So I'm going to erase that. Next one we're looking for is from K to Y. So all the way from here to here. All right. So there's, I guess, a few ways to do this one. So I'm going to set up the equation for the centroid, and it looks like this piece here is 1/3 of the whole segment from K to Y. So that means that 1.8 equals 1/3 of KY. All right, so in order to solve that, I'm going to divide 1.8 divided by 1/3. Okay, so I'm grab the calculator, and it's 1. Actually, let me get the pointer here. Okay, so 1.8 divided by, and then 1 divided by 3. So that's how you type it in the calculator, 1.8 divided by 1/3. Hit enter, and that gives you the whole segment KY, which is 5.4. So that one is definitely a little bit trickier than some of the ones we were doing earlier. And make sure you put your units, that's inches. Okay. And last one, ZJ. So let me erase that and find where Z and J are. So there we go, that entire thing. So this one is telling us similar information, but it looks like it's giving us that the 8.2 is that 2/3 piece. So in this case, ZJ, I'm sorry, 8.2, let's start it that way. 8.2 is 2/3 of the whole thing, which is ZJ. Okay, so again, use a calculator. So you guys have to figure out how to use each one of your calculators because they're all a little bit different. So for my calculator, I'm going to take 8.2 divided by 2/3. So we move the 2/3 over by dividing. So it's 2 divided by 3. And then we get 12.3. Inches. Okay, so those ones were definitely a little bit trickier than the maybe the example that I did. I would tell you that probably on the test it's going to be more like these ones we did here, where it gives you the whole segment and asks you for 1/3 or 2/3 of them. But it could be one like this also, where it gives you the 1/3 or 2/3 part, and you have to find the whole thing. So it could be any of them. So the last thing we're going to do on this particular section is talk about an altitude. So every triangle has 3 altitudes. And I'm also going to use a different word here. You guys have seen altitudes before. Usually we call them heights. So think about like when you were asked to find the area of a triangle, it's 1/2 base times height. That height is the same thing as an altitude. So the altitude connects the opposite side to the opposite vertex to the opposite side at a right angle. Okay, so these all have to be right angles. So these ones, I'm just going to eyeball them all in here, but they look like this. Okay. So there would be the 3 altitudes for that triangle. This one's a little bit easier to draw, actually. So I'm going to connect this one to the opposite side perpendicular. If it's a right triangle, that is your altitude. So the side of the triangle is your altitude. Same thing here. That side is the altitude. And then this one goes right down the middle, perpendicular. So the big thing is you're looking for the perpendicular part. The last one here with the obtuse triangle, this one is definitely a bit tricky, okay? Because if I try to connect this to perpendicular to the opposite side, like that's definitely not perpendicular. That's not even perpendicular. So where does it have to go? These actually have to go outside of the triangle. So you have to extend that piece and then it meets out here. So that right there is the altitude. So the altitudes don't have to be inside the triangle like the medians or the angle bisectors. They can be outside of the triangle. I'm going to switch colors to do the other one so they don't get all confused here. So that's that one. This one I would have to extend also because it's going to drop down here perpendicular like this. And then the last one, that one's not bad. It goes in the middle here. Okay, so those are the altitudes of the triangle. And the point of intersection of the altitudes is called the orthocenter. Okay, so the orthocenter can be outside of the triangle, and the orthocenter is one that I'm not really going to test you on. You might have to know the definition, that it's the point of concurrency of the altitudes, but that's it. So it doesn't have any theorems like the centroid does with this 1/3, 2/3 relationship, or some of the other problems we did with the midpoints and the bisecting and all that stuff, okay? So that one is probably the least important one out of all of them, but make sure you know the incenter, the circumcenter, and the centroid that we did today. Okay, and that's going to be it for 8.3.